Hello, everyone. My name is Chloe Fisher, and I am a freshman here at the Mount. I am a biology major, and after I graduate from the Mount, I plan to go on to PA school to become a physician's assistant. Our biodiversity project looked at the northern versus southern flying squirrels, and we were comparing and analyzing how the masses and the lengths of them were different based on their geographical location and whether or not the climate there was cold. My group members were Madison Shoup and Kami Velasquez.
Hello, I'm going to introduce myself real quick before introducing the flying squirrels. My name is Maddie. I'm in the biology program. I'm a sophomore and my concentration is on physician assisting. So, flying squirrels fall into the classification of mammals in the genus of Glaucomus. Flying squirrels are also often referred to as gliding squirrels, as that name is more accurate. These squirrels are not capable of true flight, and they more so glide through the air. Their ability of flight is due to a membrane connecting their front and back legs. This membrane allows the squirrel to glide through the air when jumping from tree to tree by simply extending their limbs. The animal is able to control the direction by moving its legs slightly and using its tail as a braking mechanism. In one single launch, a flying squirrel can travel more than 150 feet. There are currently two known native species of flying squirrels found in the United States: the northern flying squirrel, Glaucomus sabrinus, and the southern flying squirrel, Glaucomus volans. In our project, we hypothesize that the northern flying squirrel will have a larger average body mass than the southern flying squirrel based on Bergmann's rule that states that species at higher latitudes have larger bodies in order to accumulate heat.
We kicked off our project with a research process, and we used a website called Vernet to collect the data about the body mass and the length of both the northern and southern flying squirrels. And from there, we sorted the data down to 124 specimens each, and we did not use any data from before the year 2000. We also narrowed them down based on country, so no specimens that were found outside of the US were used in this project. Additionally, specimens who were classified as juvenile or subadults were filtered out just due to the fact that they are not fully grown and would have smaller masses and shorter lengths. And after we had collected all of our data and sorted through it, the average variance and standard deviation were calculated. Using this information, a hypothesis test was performed to determine whether or not the data could support our claim.
Starting with the first part of our raw data that we collected from vernet.com, we found that Glaucomus sabrinus, which is the northern flying squirrel's average weight, was 124.43 grams compared to the southern flying squirrel's 61.23 grams. Then the northern flying squirrel's mean length was 299.09 millimeters, and the southern squirrel was 226.01 millimeters. Not that much difference there. The standard deviation of the weight for sabrinus was 33.94, and for volans it was 14.8. And then the standard deviation for the length for sabrinus was 21.81, and for volans it was 25.79. Now, looking at this data, there's not a whole lot of difference between the length. It is still proven that sabrinus is longer than volans. However, the more interesting piece of data is the comparison of the weights. So from the data, the southern flying squirrel is about 50% smaller in mass compared to the northern flying squirrel. This then supports our hypothesis that the flying squirrels would align with Bergmann's law. So to start with visual comparisons, this was a nice little bar chart that shows the mean length between Volans and Cybrinus and the mean mass between them as well. And from the bars, you can obviously see that Cybrinus, the blue bar, is quite larger than Volans, the red bar. In this slide for our results, I created a scatter plot of the relation of Glaucoma cybrinus mass in grams and the decimal latitudes where they are found. This visual aid just helps show how the mass of the squirrel is related to the latitudes. As you can see, there's a lot of groups around the same area where they're at the latitudes. They're not a whole much bigger, around about a little after the 45 decimal latitude. We can see a couple outliers here around the 200 grams, but for the most part, as the latitude increases, their mass increases greatly, as seen in around like 55 and 65, especially 65, we can see the increasing in the mass. Seen here is like the previous slide, except with this one it is Glaucomus volans, the southern flying squirrel. Here it's not as accurate because much of the data from the southern flying squirrel didn't include the decimal latitudes, so this is not the complete sample. You can see how it slightly gets bigger according to their latitude, but there's not a whole lot of correlation based only on Glaucomus volans. This can be assumed from the fact that they're not as northern as the northern flying squirrel, so it's not as cold. They don't need to be much different in mass compared to the other squirrels. Here in this last slide for our results is our statistical analysis. And for anyone who's not very familiar with statistics, the null hypothesis is basically the claim that you make to be proven. So our null hypothesis was that the average mass, represented by X here, of the northern flying squirrel would be greater than or equal to 62 grams, which is an estimation of 1 upward of the southern flying squirrel's average mass. So taking the data and testing it at the 0.05 significance level, it was proven that we should fail to reject the claim that the northern flying squirrel's average mass was greater than or equal to 62 grams, and statistically we failed to reject the null hypothesis because the p-value 0.9671 is greater than 0.05. This conclusion then supports our overall hypothesis that the northern flying squirrels would be larger in mass to accumulate heat, aligning with Bergmann's law.
Hi guys, my name is Kami Velasquez. I'm a freshman majoring in biology here at the Mount, and after I graduate, I plan on going to veterinary school and become a veterinarian. So our experiment is based on Bergmann's law, which states that animals in higher latitudes should be larger and thicker than those closer to the equator in order to better conserve heat. So the data we collected does prove that law, and it does apply to the northern and southern flying squirrels based on the fact that northern flying squirrels are larger in mass and length. So as I said, these northern squirrels have larger bodies because they need to accumulate more warmth, and these animals are known to travel in groups and huddle together in groups of up to 50 in order to increase their warmth. So while the northern exhibited bigger mass than the southern, the squirrels within the same species also exhibited bigger sizes at higher latitudes.
Our project specifically compared adult species of the northern flying squirrels to the southern flying squirrels, and from our results, we were able to conclude that the specimens of the northern flying squirrel were larger than the southern flying squirrel. When it came to mass, the northern flying squirrels were about 50% larger, and in terms of length, they were also slightly longer as well. So if we were to do additional research and build upon our findings from this project, I think it would be really interesting to see if this size difference holds true for the other stages of development in the squirrel's life, such as when they are considered juvenile or subadult. An additional study could be done by collecting data for the juvenile and subadult southern and northern flying squirrels, and then comparing them to determine the relationship between the squirrel's size and the stage of the development that they are in. It would be expected that the juvenile and subadult southern flying squirrels would be smaller just simply due to the fact that the adults are smaller. So the data that we collect for this additional study would be able to determine if the size difference is consistent throughout the species development, or if the species actually start out as having similar measurements when they are juveniles, and then the difference becomes more significant as they approach adulthood. So when we were filtering out the data for our research, we found that the male and the female do not differ in size, and the gender of them really didn't affect the mass or the length, so we didn't discriminate or filter them out based on gender. A possible error in our data, however, may occur because the information regarding the age of the squirrels was completely missing for the southern flying squirrel, and many of the northern squirrels also lacked this information. More specifically, most of the data failed to specify whether the specimen was a juvenile, subadult, or adult. So for a few of the specimen that did list the age, we filtered out the ones that were listed as juvenile and subadult due to the fact that they were not fully grown, so they would likely have smaller masses and lengths than the adults would. The specimens that did not specify the age were assumed to be adults. This assumption, if incorrect, could skew the data, because this study was designed to compare adult specimens of each species. So if squirrels that were not fully grown were mixed in with our data, it would cause the average masses and the average lengths of the specimens to decrease and not be accurate.
So for the northern flying squirrels, we gathered our data from locations such as New York, Oregon, District of Columbia, Wisconsin, Idaho, Montana, Alaska, Washington, and Michigan. So as you can see, these places are generally very cold, and these temperatures are the range of temperatures that you find in January, because January is the coldest month for all of these places. So in order for the northern flying squirrels to survive, they need to be larger and heavier in mass and size compared to the southern squirrels, because the southern flying squirrels don't really experience these cold temperatures. As you can see in Idaho, the lowest is -2 degrees, and like Alaska is 9.3 degrees Fahrenheit, and even in New York where it gets pretty low to 3 degrees Fahrenheit. So again, like the northern flying squirrels are larger in mass because they need to be able to survive during the winter. So for the southern flying squirrels, you can see that we gathered our information from a lot more areas. So there's Florida, Georgia, Texas, Arkansas, Tennessee, Illinois, Indiana, Massachusetts, New Hampshire, Wisconsin, and Rhode Island. So as you can see, these temperatures are higher than the northern states for the most part. Like there's Florida, which the lowest is around 52.4 degrees Fahrenheit, and these are all for this month of January, since January is the coldest month for all of these states. So Since the southern flying squirrels have a lower mass, they are found in higher temperatures because like their body isn't used to the cold and they haven't evolved to live in the lower temperatures compared to the northern flying squirrels. So for the southern So this is a continuation of the southern flying squirrels temperatures. So we have more states such as Missouri, West Virginia, Virginia, Pennsylvania, California, North Carolina, and Maryland. So for this one, like California, very warm in temperature, especially for January. It ranges from like 48.5 to 68.1 degrees Fahrenheit. So again, you'll see a lot of southern flying squirrels in this area compared to like West Virginia or Missouri, because again, the smaller body size reduces their likelihood of survival in the colder temperatures. So for our conclusion, our data did support our hypothesis that the northern flying squirrels would be larger in mass than the southern flying squirrels. We found that the northern flying squirrels were approximately 50% larger in mass. However, their lengths didn't really differ significantly. So again, this relates to the Bergmann's law that animals at higher latitudes are bigger in size compared to the ones that are closer to the equator, because the ones that are farther away need to have a higher mass to accumulate more heat and survive the cold weather.
These are the resources that we used to help us complete this project and where we found background information on the northern and southern flying squirrels. And for our data, we used VerNet.